want to do that is up to you. There's going to be a huge code tidy, there's going to be a big rewrite. And as I mentioned earlier about the hashes, you can actually profile people's key on the server, because all you need is access to their API documentation, or you can even talk to a developer, ask him about some of the methods he's implemented. And if you know his method names and the objects that he's passing as parameters, we can work out his hash. So even through social engineering or available API documentation, we'll be able to generate the hash ourselves, and that's going to save us a big legwork for the kind of brute force attack. The stub that's going to be automatically created is going to do fuzzing for you. It's going to have exception handlers in. It's going to understand what's happening at the business logic layer. It's going to have specific Java payloads in. If you want to look at some specific Java payloads, I recommend checking out the Java OWASP gotchas page, which I've been writing. Thank you for some of you who have been helping implement some of those features there. So it's going to be attacking the Java API and making a lot of the business logic layer fall over, a lot of the features that developers don't know about that you can take advantage on. And I'm going to multi-thread the hash attack. I'm actually going to develop it either in C++ or assembly. I'm actually going to mess around with the sockets. I'm going to do the packets. I'm going to make it very, very fast. I'm not going to use Java to help me do this. I don't want to write objects onto the wire. I need to make it very fast. I'm going to construct my own packet, deal with the TCP IP connections. I'm going to really speed up the hash attack. So, as promised, we looked at the RMI architecture. We saw what makes an RMI service. We saw what makes RMI tick. We looked at where the fundamental flaws lie within Sun's RMI implementation. We looked at why RMI is insecure. If you actually read some of the code generated by the RMI CTOol when you're creating your stub and your skeleton, you're actually going to see there's a comment in there by Sun saying do not edit. But I kind of beg to differ, and I'm sure you guys do now. You need to edit it to make your RMI service secure, secure your lower layers. And we looked at RMI Spy. This is the only tool which is being developed publicly to assess RMI services. I'll be making it available in the coming weeks. I'll probably open it as a OWASP project, so it'd be great to have any kind of Java developers, any people who are interested in RMI to help contribute to this. And we looked at how to secure RMI. We looked at how to enable logging, things you need to think about with the authentication, the authorization, implementing a proxy, and changing the skeleton. Well, thank you very much for listening. I hope a lot of you haven't covered RMI before, have kind of learned a lot more about it, and you're going to be a bit more wary about implementing your RMI services in the future. So is there any questions?
Well, how long does it take you to break a hash, and what information do you have relating to that the functions you input to the hash function are weak? You made that claim that I haven't heard of.
Sorry?
You're making a claim that the generation of the hash key is weak or something.
Yes.
I mean, what information do you have? I mean, is it a deterministic algorithm? Do you know it?
I kind of put a comment up on the slide saying I'm still doing some more analysis on that, but the message digest which is used, it's not actually seems to be implemented correctly. Sun are moving around some of the bits, so they've generated SHA hash, and they start kind of mixing some of the data around. So it's not clear what they're actually doing. It's going to require a lot more analysis and gathering some more kind of static ID to see what's happening. And give you an idea of where's the best place to actually attack. As I said, there's actually 2 trillion keys missing at the Sun's implementation. So what you'd expect at least 18 trillion keys from a 64-bit value, but it's already down to 16 trillion. I know that's still a large number, but it's through further analysis, it looks like actually might be more of a 32 to 48-bit key. In terms of the key space.
But even if I take if I take things that are functionally near and hash them, they're not going to be close after they're hashed. So, I think you either have to know the algorithm generates the input to the hash to get it.
Yeah, you have to know the API documentation if you wanted to generate your own hash. I would ask you, I'd say, what's one of your, as a developer, I'd say, hey, what's your API documentation? Have you got any copies of your API documentation? Based off your API documentation, I'll just pass the method name in, and then I know what your hash is for your methods.
Can we take this question offline because we're running short on time? One or two more questions? Raise your hands up.
You found that you basically